Welcome back to Data Architecture Day, sponsored by the Triangle Area SQL Server Users Group. So for our next presentation, we are going to have Solomon Rutzky talking about the topic of certificate signing. So Solomon was in here, he just dropped out, but he'll be back very soon. So here we are. Solomon is now back in the office. Welcome back, Solomon.
Hello. I am now sharing. There we go. Are we there?
We are.
Okay. Hello. I'm Solomon Rutzky, and today I will be talking to you about module signing, which is using certificates to increase security for stored procedures, functions, things like that, without opening up additional security holes. And real quickly, for those who are not familiar with the reference to the title and that initial image, it was The Simpsons' take on Dr. Strangelove. Okay, so first a little bit about me, real quickly. I work for myself, founded a company, SQL Quantum Lift. Currently selling SQL Sharp. It's a SQLCLR library of functions, and very soon to release OmniExec, a multi-threaded, multi-server, and multi-database query tool. I blog at SQL Quantum Leap, slightly different than the company name. That was for trademark reasons. You have to talk to lawyers about that one. So I've been using databases for over 20 years, SQL Server about 20 years, and more recently, for the past 8 to 10 years, have been specializing in SQLCLR, module signing, and collations. I also have written a bunch of articles on SQL Server Central, including the Stairway to SQLCLR series. Okay, so for today, what I want to mainly accomplish is explaining how this stuff works more than going over all the different ways to implement it, because there's a huge variety of things like that. And there's a lot of technicalities that we could delve into with a deeper dive if there were time for that. But right now, the main goal is just to explain the basic concepts, because module signing it's been around for 15 years, but has not gotten a lot of traction. And I'm pretty sure my guess is that the reason for that is that there's not been a clear understanding of what it is. There's not good documentation out there. I'm trying to rectify that with a lot of blog articles that I'm doing, but so just the main concept is the main goal here is just to explain the concept. So hopefully these things become clear and easier to implement, and people become more familiar with it and do these things, because this way really is better. So we'll start talking about typical problems that people have, the basics of security, and so where those the typical way people solve those problems, what's wrong with those typical methods, and then we'll get into module signing and why that's better. And I do have some examples to walk you through. And as always, if there's questions, please go ahead and ask them in chat, and Kevin will go ahead and relay those throughout. So for the common problems are, and there's probably more than I've listed here, but just to start out, there are permissions that you want to grant to an application or a support person or whatever that isn't specifically a permission. You want it to be, but it's not. A good example is a truncate table. You can't grant truncate table to somebody. You need to be a database owner, or I think the owner of the object itself. And for an application login, you're certainly not going to be either of those. Or there's also permissions they're kind of there, but they're too wide and they're not granular. They're too wide in scope. The main example that I usually go with is wanting to get information from dynamic management views. Sometimes you want a login to. There are a lot of dynamic management views to get information from, and you might need to get some information about connections or current requests or session information, things like that. but you don't want to give everything else, there is a permission, server level permission called view server state. But if you grant that to a login, then they automatically get permission to see everything and all the DMVs. You can't just say, I want one or two, or things like that, or even a subset of rows or columns in those things. Dynamic SQL, this is usually a huge security risk area that's complicated. So, well, I'll get into that later. That's just really messed up. Cross-database operations, by default, databases are kind of insulated. And so even if you have the same accounts or principals in different databases, you don't usually aren't allowed to bridge between them without doing additional stuff. And if the objects are owned by different accounts, that gets even more complicated. Restricted databases is similar to cross-database operations, but there, with cross-database operations, you're assuming that the account has access to both. They're just executing something in one that needs information from another. With restricted databases, is where sometimes you an application is allowed to access one database. It needs information from another, but you don't want them outside of that particular operation. You do not want them to have any access to that database at all. And of course, loading SQLCLR assemblies, that is an area where certificates help. We're not going to get into that today because that works slightly differently, but that is still part of this. So with those problems that people typically face, the three easy and primary solutions that people go with are impersonation, which is the execute as clause or statement, where your principal actually becomes a different principal, usually DBO or something like that, because that's where a lot of the permissions are. Cross-database ownership changing, that is either server or per database level configuration option. And everyone's favorite, enabling trustworthy. So just to get into the basics of what these things, the basic mechanisms of security. So you start out with logins, which are at the server level. A lot of times people use the terms login and user interchangeably, but they are two distinct things. So you have logins which are only at the server instance level, and I prefer to say instance, not server, because server could refer to the operating system. So logins are at the instance level only. That does not mean they have any access to databases. That just means they can authenticate to SQL Server, so basically using a password to get in. And so there's the SA account that the login that people have heard about or used, that is always has a principal ID of 1 that doesn't change, and it will always be an administrator. You can't make that not administrator. Users, those are only at the database level, and you can have users that don't have a login, and so there's no instance level permissions there at all. So most of the time, logins and users have SIDs or security identifiers, and between the two, at this instance level and the database level, for the account to be the same, they would need to share the same SID, which is a security identifier again. The names can be different. The names really aren't used for much outside of when you're typing in T-SQL. When you log in, you have to use a name. You don't use a number. When you grant permissions, you use a name. It's not their SID. But internally, the way security is handled, everything matches up to the SID. There's a guest user that's built into every database. By default, it's turned off. And you should probably keep it off unless you absolutely need to have it on. I believe it's enabled in master, probably in TempDB and MSDB. But otherwise, in your user databases, you should keep that one off. That's to allow logins to gain access to a database when you did not actually create a user for them. There's the DBO user. is not necessarily it's the database owner. They have rights over the database, not necessarily the server. A lot of times people confuse that, and a lot of times it gets confused, which is a security issue in itself, especially as we'll talk about that when it comes to trustworthy. But the database owner is really just over the database, and we'll always have a principal ID of 1. The SID will change to whoever you change the owner of the database to. The reason why it becomes a security conflict is because often, much more often than it should be, people set the owner of a database to SA, which is the system administrator, which then links those two. But if it's not SA, if it's the database owner of your user database is not SA, then there's no necessarily link to for administrative access for the database owner. Okay, so principal IDs, these are the internal SQL Server only IDs. Think of it as like an identity table. So you have database principals and server principals. They each have this integer principal ID, and it's used to basically to foreign key stuff at their particular level. There's really no other meaning behind those, and you don't usually need to worry about those. The SIDs, this is really where the security happens. If you're using Windows logins, Windows operates on SIDs, and so do other operating systems. There's actually a standardization of how SIDs are formatted and how they work. And there is meaning to the numbers. As you can see in those last two entries here, there's a binary format there, there's a string format, and there is a relationship between these. There's an algorithm to convert one to the other, and there is a specific meaning behind it. They all start with S-1, but the 9, that means a certain type of login. There's 6s, which are other types, and some of them are actually shorter. And there's like this, you have these groups right here of digits, and there's some of them only have like 2 groups, depending on what type they are. Some Windows groups might have only like 2 or 3 of those, things like that. But the SIDs, that's really what makes security work. That's links like when you have a Windows login, it brings the SID of your Windows or Active Directory account into SQL Server as the SID. And then if you then allow that login to have access to databases, it then copies that SID again into the SID for the database principal within each database, which you can then see in the sys.database principals view. So just to give a graphical overview of the relationships here, we have at the instance level, we're going to assume that there's a login Bob with this SID. It's not a realistic SID. That doesn't really matter for now, just to see the relationship here. And with a principal ID of 301, again, the principal IDs are irrelevant. They don't match up to each other. They don't need to. What's important here is that Bob with this SID is also Bob in database 1, same SID, even though they're different principal ID, doesn't matter. In database 2, they have a different name, but with the SID is the same, it's the same account. Database 3, they've got the same SID because that's how you know that it's the same account, because really it's only the SID that determines which account is which. But because it's the guest, they've got a principal ID of 2, their name is guest, and this one actually had clearly database 3 had the guest account enabled. So real quickly, I'm going to switch over now to a demo. I just came up with these, so hopefully they work out. But hopefully this will make things more apparent. I'm using SQL Server Express LocalDB, and I believe I already deleted everything, so I'm going to go ahead and I'll make sure I had already deleted it. So fresh install. LocalDB is actually excellent for doing demos. It's very lightweight, small, easy to delete and recreate an instance. So this is a brand new local DB instance of SQL Server 2019. And so here we are. If I need to enlarge anything, let me know, or mention it in chat, and then Kevin let me know. But here we need to. I was connected before, and I actually lost the connection, so there's going to be an error first. But now we're back. So what I'm doing here is I'm going to create 3 databases, A, B, and C. So there's A. I'll create B and C all together. You don't need to worry about the specifics of those. They're just generic, nothing special. We're going to create 3 logins, an owner for database A, a separate owner for database B, to show the benefit of using certificates and module signing with cross-database ownership chaining, with cross-database queries, and then our application user. Those are bad passwords, but we're not going to worry about it since this is just a silly test. Anyway, here I'm going to, when you create a database, the database initially has an ownership of whoever created it, or restored it, or attached it, which right now is me, so I'm going to change those to their respective owners, A for A, B for B. Then, last thing, I'm going to enable the guest account on database C. By default, it is not enabled. And in database A, I am going to create an account or a principal and a user for our application user. And we have, so far, just one utilities stored procedure, which will tell us who we are. Great. So far, scripted demo is actually working. We're going to start. We're going to get an error here, probably. Oh, great. We didn't. So, and I will try to enlarge this a little bit. There we go. Okay. And then if I do, let's see, Control-4. There we are. Hopefully this works. Hopefully it's not too grainy. We can see that we're currently in the master database. This section up here just shows us who we are currently. This is my login. That's my account, which is the Windows account. And I am DBO because we're in master, and I'm an administrator. This is my SID, which is what shows up in Windows as. So another thing, logins have a system name, which if it's a Windows account or Active Directory account will show that. Otherwise, it will show if it's a SQL Server account, it'll show the same SQL Server name as your as the login. And this is if there's impersonation, this will always say the name the principal that you logged in as. So here are the security tokens. This is at the instance level, which is for logins. Down here is the database level, which is for users. Nothing terribly interesting or surprising here. So now we're going to use database A. And my information is the same, who I am. Actually, nothing has really changed here outside of the database has changed. That's one benefit of being a system administrator. You are always a system administrator everywhere. You're always DBO in all databases, which was why some people use it so often, because it's easy, even if it's not as secure. Here we are going to now use this as impersonation. Execute as I'm going to become the app user application account. Still database A, obviously. And we can see that now, since we did the impersonation, we are app user for both login and user. And you can tell that there's impersonation going on because original login still shows who I am, or who I signed in as originally, or who I authenticated as, but here it shows that we are now temporarily the app user, which, and again, these are the different SIDs than they were a moment ago for me, but this is the app user SIDs. The only thing that's different here that I probably should have pointed out before is this deny only. Before they were grant or deny, just like it shows right here. And what that means, since it's at the instance level, since these are logins, what this means is you are confined to anything that you do as this user right now is confined to this database. You can't go up to the server level for server level permissions, such as view server state. You can't go to another database for anything. You are quarantined to the database you're in because you are denied access to anything else. All you can do is you're basically fine here. And that is actually where a lot of people get into trouble, and why they start employing those other methods that I was telling you about, or actually that's mainly why people enable trustworthy, because trustworthy gets around that deny only. Not the best way to do it, but that's what it does. And people don't always understand why their process stopped working when they, for example, had a stored procedure that said execute as DBO or execute as something in order to do, say, truncate table, but then they needed some server level permission as well, and that no longer worked. Now, very similar, a moment ago we did execute as a user. Now we're doing execute as login, which is the instance level account. And what we can see here is all this SID stuff is the same. What I want to show you is at the login level, the instance level, we now have grant or deny because we impersonated the login, not the user. And we're not going to revert this yet, but again, just to show you the difference, there's execute is user, which is database only. And when you do that, you are confined to the database. And if you have running a stored procedure that has the clause in it, create procedure blah with execute as, say, DBO or execute as owner, that qualifies as being similar to this right here, and it is by default quarantined to the database. Execute as login can only be done as a statement, like is being done here, and that is less restrictive, obviously. Why I did not revert yet is because, remember, I created the login for app user, and I created a user in database A. I did not create a user in database B or C. Trying to access database B, I get this error that the principal app user is not able to access the database. So that's good. That's what we want. We don't want app user to have any access to database B. Database C, well, no error there. Let's look at our security info, and we see we are, in fact, guest. That's ID2. We still have our SID because that's how it knows who we are, but we are, in fact, guest because I had granted connect to that user only in database C and only for the purpose of showing you this and how that works. Generally speaking, we don't usually use the guest account, although that is how MSDB works. We're going to go back to database A because you cannot revert in a database that's different than where you did the execute as from. Otherwise, you get an error. This will just show that we are, again, right back where we started. Okay, so hopefully, even though that was a little quick, hopefully that gets the gist of what these IDs are and how they work at the instance level, database level, and how they simply differ, like where the guest account comes in, and how doing execute as user quarantines you to the local database. So, in terms of assigning permissions, this is the easiest, most basic built-in part is ownership chaining, and basically that just states that when you have a module such as store procedure, trigger, function, that the owner of that object So most people still use just DBO, even though you can create a schema of whatever you want. But let's just say for now, DBO. Any other DBO-owned objects accessed in that object, as long as it's a DML statement, so insert, update, delete, a select statement, or exec, it is assumed that if you had permission on the outer object, that for objects owned by the same owner of that object, you are also allowed permission to do the DML select or exec statements. The reason for doing this is that it's a performance benefit, so you don't have to basically check permissions and on every single object in the whole chain of things, which would hurt performance. But interestingly enough, you can also, because it skips the security check on all of the lower objects or the referenced objects within an object, you can technically bypass a deny, which is not supposed to be able to happen, but in this one way that can happen. So if you had like a deny select on a table, but you had execute permission on a stored procedure, and that stored procedure selected from that table, the deny would never be seen because the system knew that you were granted access to that stored procedure. And then since the table was owned by the same principal ID, it just ignored it. But this only works by default within a single database. Accessing objects owned by that same account in another database, that's where cross-database ownership chaining, which is a separate configuration option, that's where that comes in. Dynamic SQL, well, whenever security is involved, dynamic SQL breaks everything. But definitely with even if you're still accessing objects owned by the same principal ID as the one that owns the object that you have access to, then dynamic SQL breaks the ownership chain and the implied permission. So you have execute permissions on a stored procedure. It is selecting from a table owned by, they're both DBO dot, objects, but because it was done in dynamic SQL, no assumptions are made about permissions. The permissions will be rechecked every time, and if you did not have direct explicit permissions on it, such as insert, update, delete, select, or execute, or if you don't have implied permissions that were granted through group membership, such as like DB, data reader, data writer, things like that, you won't have access to those objects. This is one reason why some people in procedures will use execute as DBO, because there's dynamic SQL, and they need that person who's ever executing it, execute permission on the stored procedure clearly wasn't enough. They want the dynamic SQL to work as well, so they just say execute as DBO and move on, even if that's not the best. So what I'm trying to do here is show the relationship between things. So here you have the green face is your principal at the database level. By default, does not have any DML or whatever permissions to anything. One of the reasons why we use stored procedures in the first place, not just to encapsulate stuff and create an API for the application, which is definitely a huge benefit and nice, but also it does the implied permissions through ownership chaining. So you can basically grant execute on module A to the application user, not give them select access or insert, update, delete, or anything to the tables, but because they have execute access to module A, let's say it's a stored procedure, then they can do whatever those operations are, as long as they're, again, the insert, update, delete, select, or execute. Dynamic SQL, again, breaks ownership chaining. You also do not get access to other databases, nor do you get instance level permissions, which are things, again, like view server state, or things like that. So impersonation, the problem there is it's basically there instead of permissions. You're swapping out who you are. So we were, as you saw when I did execute as before, when I did execute as login app user, my SID was removed from those tokens are basically the like what's currently there in the security context, and my SID was removed, and the app user SID was added. So it was a completely different set of permissions. And this is basically what when you use impersonation, you're basically creating a login and or user who ideally that they have all the permissions you need, even if it's more than you need in some cases. But basically, you're just saying that this account has all the permissions, whether it's to execute certain things or insert, update, delete, whatever. That account, they can do whatever they need to do. And you can, again, as you saw with the demo, you can accomplish that by doing the execute as clause or statement. I was showing you the statement in that demo, both for the user and the login. The difference between the clause and the statement, again, what I showed you before was the statement. The clause is part of the create, procedure, create function statement in the with. So a lot of times you'll see create, procedure dbo dot something with execute as owner or dbo or user somebody. The statement, as you saw in the demo, I was able to do execute as login somebody, app user. When you do as a clause, it is always a database user. There is no option to do a server level login, instance level login with the execute as clause. And a lot of times people try to say execute as DBO, trying to get server level permissions like view server state. But again, it's just database level. And again, when we're using execute as, it's automatic for a user, which is the only option you have for the clause. It's automatically quarantined to the database. So it's even harder to get to the server level when you do that. Also with a clause, you don't need impersonate permissions. When you create the object, as long as the person creating the object, and if it's a rollout process that you have, like an automated rollout process that you have, that's typically an administrator, and that's going to have permissions to everything. But basically, as long as the user creating the object has the impersonate permission for whoever they're saying to execute as a clause, then that is assumed for whoever executes the procedure. So somebody executing the procedure cannot necessarily, so a procedure, let's say, has execute as DBO. The application user is given execute permission to that sort of procedure, and they can run it, and when it's running, they are DBO. But outside of that, they can't do, like I was showing you, they can't do execute as user equals DBO because they were never given impersonate permission on it. So that's, again, a nice thing about the clause is it kind of sidesteps the need for explicit impersonate permission. The statement, if I wasn't an administrator, then in the demo, I would have had to have had impersonate permission for app user. Cross-database ownership chaining, there's instance level and database level. Instance level basically turns everything on. And at that point, the DB chaining database level option doesn't do anything. But if the instance level is off, then DB chaining, which is a database level setting, that can be turned on a per database basis to allow for fewer than all of the databases to do that. Again, for cross-database ownership chaining, the SID of the owner of the object needs to be the same in between both databases. And the user executing the module needs to also be in both databases, but in the second database, they don't need any explicit permissions because the ownership chaining is going to assume those permissions. So if there's a table in another database, the app user would need simply to exist in that other database. They wouldn't need select permission on it because that's the whole point of the ownership chaining, is that's supposed to assume the select permission if they were executing a procedure in the first database that had in it a select statement for the second database. Again, dynamic SQL breaks this, as it breaks any ownership chaining. And if you can fix this with trustworthy on. That's what most people do, because it's the easiest to understand, easiest to do. It's just one statement per database, but it works, unfortunately, because there are problems with that. So trustworthy, as we've been talking about, it's off by default, thankfully. And what it does is it basically tells the instance, because trustworthy is at the database level, and it tells the instance to allow its users to be assumed that if there's matching SIDs between it and the instance that it's on, that they're the same. And it's off by default because you could be restoring or attaching a database that came from a different instance, and there could be matching SIDs, especially if you have, if you're using, let's say, SA as the database owner, which is SID1 everywhere on all instances, doesn't matter, who installed the SQL Server. The other SIDs might change, likely will change, but SID of 1 never will. So if you have SA as the owner of a database, and you have code that's executing as DBO, which is then the owner, which is then SA, trustworthy will allow the data, will basically remove the quarantine. So here, this was just, again, trying to quickly show these three different options and how they affect everything. From before, we had lots of red arrows. These bottom two were green in the last slide that had this image. By dynamic SQL was red, but now if you use execute as, like execute as DBO or whatever, that breaks. That basically allows the permissions to work in dynamic SQL. Getting to other databases can be done with DB chaining. Trustworthy allows you to get up to instance level access. It also does help with DB chaining as well, or cross database queries. But it's the only thing that will get you instance level access outside of module signing, which I will show you. So with cross database ownership chaining, actually with all these, in order to get more time for demo stuff, I'm going to kind of go through this quickly. These slides will be available afterwards in a couple places if you want the details. But basically, they all allow for unintended elevation of permissions. It's really what it boils down to, and why these three things, cross database ownership chaining, impersonation, trustworthy, why they're security risks, because they do accomplish the goal, but they also leave the door open for unintended things to happen. And we all know that we hope for the best, but people do sometimes abuse things. So the better way is using certificates. So module signing, and before, remember, impersonation was instead of, because you're basically swapping out one principal for another. With module signing, you are simply adding additional permissions to who you are. So who you're executing as, basically let's just say the app user, will not change to some other user with either more, it won't change to DBO within that module. It'll simply get whatever additional permissions it needs. The nice thing about this is that you are assigning the permissions to the modules themselves, not to an account or principal. So you're not basically setting up somebody who would then have all these abilities to do stuff and could then do things at times when you're outside of the context of the stored procedures that you have set up. But here you're actually saying no, it's the stored procedure itself, and obviously just the code within there that has the permission. So using the signatures not only gives both authenticity, so kind of where it came from, because signatures have metadata which states, as long as it's filled out, who created the who created the certificate, things like that. But also a nice feature with module signing is it's not always. It's not set it and forget it. So basically, if when you sign a stored procedure or function or anything really, if there's any change to it at all, the thing that was signed, it loses the signature. Even if you didn't change it, if you just said alter procedure without making even a single one space or byte of change to the content of the procedure, simply doing the alter statement in the first place drops the signature. So it's not like you're granting permissions to do stuff, turn around and somebody changes that code. It can now do more than you wanted them to. Any change at all drops the signature, and then assuming that the only DBAs, or only you can add the signature yourself, then they have to kind of come to you again and say, we need this if something broke. And then you can basically say, well, why did it break? Oh, look, you changed it. So it kind of forces a code review, which is nice. So the way that you get these permissions is there is a login and a user that you assign permissions to, but that's only because logins and users are basically the container of permissions. It's the only thing that can be assigned permissions. So they're basically reused in this context, but they aren't logins and users that can be impersonated, that you cannot say execute as. The login and user associated with their certificate, they're there only to hold the permissions. So it's safe. So even though before I said it's not account-based stuff, there's no login user, there's not a login user that somebody could do something with. So the added signature statement is what does it. There are counter signatures, but you can ignore them. They're effectively useless. So what you can sign are multi-statement TVFs. You cannot sign inline TVFs because, like with views, which also cannot be assigned, inline TVFs, their definition is basically just pulled into the query itself at runtime. They're not really a module that executes on its own, which is why they're so much more efficient than multi-statement TVFs. But so you can assign multi-statement TVFs, store procedures, scalar functions, and triggers. You can also sign SQLCLR assemblies to get around the new-ish CLR strict security instance level configuration security debacle that started in SQL Server 2017. But there's a link to a blog post that describes everything about it, the problems, and how to get around it by doing this. So I'm not going to get into that now. So why would you want to do module signing? The principal that contains the additional permissions can't be impersonated. Nobody can ever become that. It's just, again, a container for permissions, but it's just kind of sitting there, not usable otherwise. You can get very granular permissions because basically whatever you have your code do, so whatever's in the module, let's say it's a select from a particular DMV where you have, where conditions that narrow it down to just a few columns and a few rows, and that's it. And you then assign the view server state permission to that procedure. Well, at that point, you really only gave permission to those few rows in that one DMV, not all other DMVs, because the code's not doing anything else. If the code doesn't do anything else, then that permission isn't being used for anything else, because again, it cannot be extended. It doesn't have the security holes that exist with trustworthy impersonation and cross-database ownership chaining. Again, the signature is dropped if the code is changed, which is, again, it's nice because it forces a code review. People can't make changes without you knowing about it. The elevator permissions are confined to the module that was signed. It doesn't move beyond that, which is different than doing execute as, because with impersonation, which is execute as. When you have that, everything from that point forward, doesn't matter what you execute, and if those modules execute other modules and so on and so forth, 100 down in the chain, once you become a different principal, from that point forward, you are that other principal. And so there could be unintended consequences of, you're allowing somebody to execute this procedure, but then you didn't realize that it's going to execute these other ones, and you didn't want them to have access to those things, but it did when you use execute as. Module signing does not. So, and you can also get a little fancy with it and create different, using different certificates, create subsets of different permissions, like one with view server state, one with something else, and use one permission for one thing, one certificate for another, but then in one place where you need both of those, you can sign a module with both of them. So you can kind of stack things that way, which is another thing that you can't do with impersonation. You have to basically give that one principal everything they need for that one operation, which might be much more than they need for every other operation that they do. So again, we have a certificate which has a public key, and that public key is really the SID, treated like the SID is the security mechanism that matches everything up. So here we're showing that. So again, this is like the app user, the green face. They have execute permission to this procedure ABC. This procedure ABC was signed with this certificate, and they share a public key. The store procedure is not going to have a public key without being signed. That's part of being signed. Is that the public key was used for that as part of this, is built in, is buried into the signature. So in order to execute, this does things in here which require additional permissions. It says it needs X, and it's going to execute this DEF procedure, which this user does not have permission to do. But over here, the user created from that certificate that was used to sign procedure ABC has that permission, X and Y, and can execute DEF. So as soon as the user executes ABC, they automatically, they have all the permissions they used to have, but now they also get these, which allows them to do X and allows them to do execute DEF. So the basis behind this, they're both asymmetric keys and certificates. Basically, a certificate is an asymmetric key with additional information. An asymmetric key has a private key and a public key. The private key they can be, these asymmetric keys and certificates can also be used for encryption. And when in that case, the private and public key are used slightly differently. But for these purposes, for code signing, the private key can be removed because it was used to actually sign the things. Then if you remove the private key after they're signed, then all you are left with is the ability to verify, which makes it even more secure, because then you can't apply the signature to anything new, but anything that was signed can still be verified that it was signed. These are, again, specifics that if you're interested in, you can go through later. Here I'm trying to, in this slide, just trying to show the relationship between, or difference between encryption and code signing, and how they slightly use the public and private key differently. It's not important for this moment. So again, I'm going to spend time on the demo instead. But really, the way this works is, and if this graphic doesn't make much sense now, hopefully it does with the demo, but the idea was to kind of show the relationship between the different components. Because again, I think this is where people get tripped up in not seeing the relationship between a certificate and the permissions to do anything or whatever. But so we're going to create a certificate. It's got a private key and public key. They're mathematically related. The certificate is going to be applied to a module with the add signature command, and that will give us an actual signature. The public key is used as the SID for the principals created from it. So we can create a login and or user from a certificate, and they will share the SID. And because again, that's how the security is done. Those are then, because the module was signed with that certificate that had the private and public key, because the public key was part of it, this for a signed module, when you use it, you keep who you were. Whereas again, with the execute as, you were one person, but now you're executing as the clown, and you are not you anymore. You are the new user, completely new set of permissions and everything. With module signing, you keep who you are, and so you got your permissions plus whatever permissions were assigned to the login and user that shared this public key. So that's the public key is really the link between everything. So the public key, again, is used to verify the signature, because what we didn't go over is that in code signing, the code itself in the module, so the statements that are there, plus the signature that is there, that was an artifact of when we signed it, and the public key, you put all three together, and you can tell whether or not it matches. So if there was even one byte changed in the code, then putting these together in the formula will not come up with a result. So that's how it knows. That's how it knows. So to go through now, so
Solomon, before you get to the demo, there was one question that I wanted to save for this switchover.
Okay.
And that is, do you know of any approaches to automate the revocation of stale users, as we're talking about users and logins?
Stale users?
Yeah, people who perhaps their accounts haven't been used in a long time or are no longer valid accounts.
I don't think there's a built-in way to do that. I mean, it would be fairly, again, there's difference between logins and users. So I'll try to answer as quickly as I can so I can get to the demo, but since that's not really part of module signing, but it is possible that you could have users, like if you restore a database, you could have users from the prior system that don't have a matching login. It should be fairly easy to go through the list of server principals and database principals and remove database principals that don't match anything in server principals. As far as server principals, so logins that are stale, I'm not sure how to even determine that they're stale, especially if they're Windows logins. But I mean, if you take out, well, actually, one way to do this, and again, this is, I'm going to end right here, this question right here, because it's really a little off topic. We can come back late, like afterwards or offline, and talk about it. But this is actually a good reason to set up your security using Windows groups, because then you don't have to worry about specific logins. You just have to worry about, outside of SQL Server, like an employee's membership in a particular group. So if you have groups for like HR or developers or support, and you have in SQL Server, you have as logins a login for your developers Windows group, Active Directory group, and a login for your support Active Directory group. Then you can set up your permissions for what those logins can do, and you don't care who's in that group. That's for your Active Directory administrator to take care of. So if somebody signs on to starts at a company as a support person in Active Directory, they would just put them into the support group, and they magically get into SQL Server by way of that group. And when they leave, then their account is disabled at the Active Directory level. Then they no longer have access to SQL Server. So if there's, again, anything more than that, we can talk about that offline. Okay.
Perfect. Thank you.
You're welcome. Okay, so hopefully we have time for all this. So what I'm going to show here is extending permission at the database only level. So basically we're confined to one database, and as I was saying before, there are certain permissions that aren't grantable, but we don't need impersonation for that. So let's see. We're using our database A, which is where app user had permission to. We're going to create the table. We're going to create a simple procedure to truncate from the table, and we're going to execute access to the app user. Now we're going to become app user, and that, hopefully you can see that we are. And we are going to execute the procedure, and bam, we get this error message saying that we can't do that. Which makes sense. It's truncate table. We're not the database owner. We're not the owner of the object. So we are going to create a certificate. And again, this is some of the metadata, the subject and the expiration date that an asymmetric key does not have. There's other benefits to using certificates over asymmetric keys, which we don't have time to get into right now. But so we have a certificate that has a password. And we can see that certificate there. It exists. Great. We're going to check right here. This is sys.crypt properties is where the signatures are held. There's nothing there. We're going to do add signature. We're going to add signature to the store procedure using that certificate and that password. It said good. We'll check back, and there we are in that database. And the thumbprint matches the certificate thumbprint exactly. The crypt, the crypt property here, that is the signature itself. The thumbprint again matches that's how you match the certificate to the thumbprint. So basically, there's the major ID is the object ID. So you put those together, major ID and thumbprint, which points to certificate, and that's how it verifies that signature matches that code. So we are going to quickly become app user again. That didn't fix anything really. Same error as before, because we did not actually assign the permission anywhere. So now we will create a user from the certificate itself. We are going to execute the procedure. Again, same error, because we created the user, which is the container for the permissions, but we didn't actually give it any permissions. So now we're assigning we're adding the user created from the certificate to DB owner. We are going to become app user. And I forgot to update that statement. That should say success. Okay, so hopefully that makes sense enough, where we created a certificate using add signature. We applied the certificate to the store procedure. We then created a user from the certificate. That user only exists to contain permissions. We added that user to the database owner role. That user, even though it's database owner, is not doing anything other than the truncate table statement, because it's not being used in any other way. And you cannot say execute as that. So we have a user. In fact, if I have 1 minute, I will, just to show you, execute as user equals, and right there, cannot execute as the database principal because it doesn't exist, or this is what it really is. This type of principal cannot be impersonated. So perfectly safe. It wouldn't matter what permissions I gave it. Nobody could ever use it unless they use the as signature, in which case they need the password, and I'm not going to tell anybody the password. So that was one last demo here to continue on from that one. So real quickly, we're going to use database B, where the app user does not exist. We're going to create a table and add a row to it. I'm going to go back to database A, where app user does exist. We are going to create a procedure that simply selects from the table in database B. And we're going, so I just need about 30 more seconds or just a minute. We are going to become app user again, execute. It says super principal app user is not able to access the database. Makes sense? We did not create a user for app user in database B. So we wanted to get that error. Here we are going to, again, add our signature to that procedure. Here we can see that there's now a second item in there, which is good. Come app user again. Same error because we haven't really done anything with the we signed the procedure, but that doesn't really go anywhere. All it has right now is database owner, but that doesn't mean anything. So what we're going to do here is we're going to copy the certificate, which is the public key only, not the private key, because we're not signing anything anymore. We're going to basically create that same certificate in database B. And that right there is the binary code of the certificate, just to verify that something was there. We are now app user and same error, even though the certificate's there. The problem is there's no user in database B. So now we are app user again. This is different. Now we're not getting we don't have access to the database. We're getting select permission denied. So now we can see that we're making progress and that the certificate is doing something because we now actually do have access to database B. We just don't have access to the can you see me table. But we actually got into the database, and all we've done is up here, all we did was create a user from the certificate in database B. So yes, good, that is progress. Now we're going to give that permission to that user. Just nothing more than select. I'm going to become app user, and at the very bottom there, if you can hopefully see it, blammo, it actually worked. And we're going to revert. It worked without creating a different login for it. So there's no instance level access whatsoever, even for the certificate. There's no instance level permissions. We didn't enable trustworthy. We didn't enable cross database ownership chaining. But there was, if I just have 30 more seconds, remember there was all that output from the who am I store procedure showing all the tokens and everything. It was kind of busy. And so let's say we come in here and we make a change. We don't want that. So come down here again, and this worked, right? It no longer works. Why? Because I altered the store procedure. It lost the signature, which is good. That's what we want to have happen. That makes it more secure. And so if we come up here to where at signature is, we can see.
You have to revert.
Good call. Thanks. Add signature. There it is. Okay, so here there's only one object now. The C stuff is not there anymore because we lost that. So we add signature. Come down here. It works again. So again, it enforces code reviews. People can't use the elevated permissions and change things on you. So anyway, back to this. There's other links to examples. A lot of the stuff I have for each of these, I have walkthrough demos with working scripts and everything on my blog, which those are links to that. Here's my contact information, as well as there's a more detailed version of the information contained in this presentation. Not only the stuff that I didn't have time to get to, but additional details and stuff like that. And more information at the link on the bottom says modulesigning.info. That's a site devoted to just this type of information, which has links to me, this presentation, and other stuff too. The walkthrough demos and a lot of other stuff. So thank you.
Excellent. Thank you very much, Solomon. Looks like no other questions, but if you have follow-ups, please feel free to reach out to Solomon or let me know and I'll pass it along. So we're going to go to intermission. This will be a slightly longer intermission, about 13 minutes before our next session begins. That's going to be Matt Gordon talking about high availability in Azure. So stay tuned. As usual, I am going to cut out the stream for a very short amount of time as I switch everything over. So thanks again, Solomon. And
thank you.
Be right back, everybody.